Okay, so I'm going to graph number 1. First, I'm going to put the vertices on there. The vertices are 6, 0, negative 6, 0. Okay, now I want to draw my asymptotes. So I know that the slope for my asymptotes will be plus or minus 1 over 6. And the center is at 0, 0. So I'm going to put my center in there. And from the center, I'm going to count up 1 and over 6. I'm going to do the positive slope first. So I'm going to go down 1 and to the left 6. And I'm going to use a straight edge to get my line. Now, I can see where my vertex is going to be. So when I draw that asymptote, I'm going to use a dotted line, and I want it to be long enough so it goes past where my vertex is. Okay, so there's my positive slope. Now I'm going to count my negative slope. Up 1 to the left 6, down 1 to the right 6. And then I'm going to use a straight edge again to draw my line. And I'm going to try to make it just as long. So I'm going to use those asymptotes as guidelines for the hyperbola. Okay, so my left side, here's the vertex. And I'm just going to draw my shape using that asymptote as kind of a guideline, because I know that the hyperbola is not going to cross over that asymptote. Okay, and then on the other side I'm going to do the same thing. So I'll just use that asymptote as a guideline. And there's your hyperbola. Any questions? Okay, let's look at number 4. Number 4 has linear terms. So I'm going to have to complete the square to get this into standard form. So the first thing I want to do is get my x variables together and my y variables together, and then move the constant, that negative 36, to the other side of the equal sign. And I want to lead with the positive variable, so I'm going to lead with that 5x squared. Okay, so I'm going to reorganize 5x squared minus 40x minus 4y squared minus 16y equals 36. And when I complete the square, I need my leading coefficients to be positive 1. So that means for the x's, I need to factor out a 5. So I have 5 times x squared minus 8x, and I'm going to leave some space to complete the square. And for my y's, I'm going to factor a negative 4 out, so that my y squared will have a positive 1 leading coefficient. And that means I'm going to have to change the sign for the 16y, because I factored a negative out of that one as well. So now I can complete the square. For my x's, I'm going to take the linear coefficient, divide by 2, and square it. So that's going to be a plus 16. So to keep that balanced, I need to add what to the other side of the equal sign? 80. Not 16, because this 16 is actually being multiplied by the 5 in front of the parentheses. So I need to add 80. 16 times 5 is 80. And then for my y's, the linear coefficient divided by 2 and squared is going to be plus 4. And what am I going to add to the other side to keep it balanced? Negative 16, right. All right, so now I'm ready to factor my trinomials. Add my constant values together. So I'm getting close to having it in standard form. The last thing I need to do is divide everything by that 100, so my equation will equal 1. And I want to simplify it. Okay, so I'm going to have x minus 4 squared over 20 minus y plus 2 squared over 25 equals 1. So a is going to be the square root of 20. And of course you want to simplify it, right? It's going to be 2 radical 5. B is going to be 5. And C I need to find. So I'm going to take a squared plus b squared, that's 45. 45 is your c squared. And take the square root of that. So after you simplify it, you should get 3 radical 5. Okay, so on this one, the center is going to be different. It's 4, negative 2. So make sure you're looking for your x to get the h and looking for your y to get the k. Don't just automatically put it in, this is x, this is y. People sometimes get mixed up with that. Now your vertices, since this is a horizontal ellipse, because x is your positive value, it's going to be horizontal. The x value in your coordinates is the one that's going to change for your vertices. So you're going to have 4 plus 2 radical 5, negative 2, and 4 minus 2 radical 5, negative 2. You want to keep that in radical form unless you're going to graph it, and then you can find the decimal value. But for your answer, keep it in radical form. Okay, and your foci points, my x value is going to change again, so 4 plus 3 radical 5, negative 2, and 4 minus 3 radical 5, negative 2. Will give you your foci points. The last thing they want us to find is the slope of the asymptote. And the slope of the asymptote is going to be plus or minus your square root of your y denominator over square root of your x denominator. So plus or minus 5 over 2 radical 5. Now you do not want to leave that with the radical in the denominator. You have to rationalize it. I know. So we're going to multiply top and bottom by square root of 5. Okay, that's going to give me plus or minus 5 radical 5 over 10. And the 5 and the 10 are going to reduce. So your final answer is going to be plus or minus square root of 5 over 2 for your slope. Any questions? Okay, we're going to do a couple more. Melanie? I'd rather you write them as individual points like that. Okay? All right. Let's look at number 5 down at the bottom. Write the equation of the hyperbola from the given information. You will need the center and the value of a and b. So we don't need c. We don't have to find c. Just a and b. On number 5, it tells us the vertices are 7, 0, and negative 7, 0. And the conjugate axis is 10 units long. So first of all, let's get the center. I can just use the midpoint for the vertices to get the center, which is going to be 0, 0. Okay, so from the center to a vertex will give you A. And what is A? 7, right. The vertex is 7 units away. And B, I can get from the conjugate axis, because the conjugate axis is 2 times B. So B has to be 5. And now I have everything I need to write the equation. Since your x value is the one that's changing on your vertices, that means it's going to be horizontal. So my x value is the one that's going to be positive, and a squared is going to go with the positive value. Okay, so x squared over 49 minus y squared over 25 equals 1. And that's your equation. Okay, I want to do one more and then we'll be good to go. Number 7. Number 7, the vertices are 8, 0 and negative 8, 0. And the asymptote slope, they give you the equation for the line, but I'm just going to write down what the slope is. It's plus or minus 1 over 6. Okay, so what kind of a hyperbola do you think this one's going to be? Vertical or horizontal? Horizontal, because your x value is the one that's changing for your vertices, so it's horizontal. So your center, I can use the midpoint again for between the two vertices. It's going to be 0, 0. So that means that A is what? What's the value for A? 8. Now for a horizontal hyperbola, the asymptote slope is plus or minus B over A. Okay, so this has 6 in the denominator, but I know that's not A because A is 8. So what that means is that B is going to be like some kind of a fraction, and it just reduced down. So we're going to use B over A. I don't know what B is. I know that A is 8, and it's going to equal the slope, because I know that when it reduces, that's what it's going to reduce to. So you're going to set up a proportion to help you solve for the B. Do your cross products. 6b equals 8, and b is going to be 4/3. So now you have everything you need to write your equation. You could write x minus 0 squared. You don't have to, though. We could just leave it as x squared over 64 minus y squared over 16 over 9 equals 1. And for this class, you can leave that complex fraction, 16 over 9, in the denominator. You don't need to simplify it for this class. Later on, they might ask you to do that, but right now, let's just leave it like that. Are there any questions?